These are some of the notes for Chapter 5. What does the median tell us about the sides of triangles, and can there be more than one median? Some of the vocabulary words we're going to be talking about in this section are the median, the centroid, and concurrent. In a triangle, a median is a segment that joins the vertex of the triangle and the midpoint of the side opposite that vertex. So if we start with vertex A and we draw a line opposite and it's the midpoint, I know that it is the midpoint because BD is congruent to DC, so therefore by definition D is in the middle since each side is congruent. I can also add a median from every vertex. So if I start at B and go to AC, I can add point E as the midpoint, making BE the median. I can do the same thing from C, and I have 3 angles, therefore I have 3 medians. The medians of triangle ABC, which are AD, BE, and CF, intersect at a common point that right now is glowing green. That common point is called the centroid. When 3 or more lines or segments meet at the same point, the lines are concurrent. From the vertex to the centroid, and then the centroid to the midpoint of the opposite side, there is a special relationship between those. That relationship states that from the vertex to the centroid is 2/3 of the entire thing. So AP is 2/3 of AK. BP is 2/3 of BL, and CP is 2/3 of CJ. So that I am working with a fraction, I always multiply by the numerator and divide by the denominator. Another relationship that we have is the length of the segment from the vertex to the centroid is twice the length of the segment from the centroid to the midpoint. So from the vertex to the centroid is twice the size of from the centroid to the midpoint. And remember that when those 3 medians meet, or when any 3 lines meet, we say that the lines are concurrent. If I want to use the centroid theorem, I know that in triangle XYP, P is the centroid, and YV is equal to 12, and we want to find YP and PV. So the first thing we're going to do is we're going to remember that YP, which is from the vertex to the centroid, is equal to 2/3 of the entire thing. This is the relationship that I use, and then I'm going to substitute. 2/3 of 12. If I take 12 and divide it by 3, I get 4, and 4 times 2 means that YP is equal to 8. So this top part right here is equal to 8. I also am being asked to find PV. Well, there's 2 ways that I can do this. One is to say that YP plus PV, so the 2 parts add up to the whole segment, and then I can substitute. 8 plus PV is equal to 12, and therefore PV is equal to 4. I can also use the theorem that I learned in the last slide that says that YP is equal to 2x and PV is equal to x, which means that I can just cut this part in half and get that YP is equal to 8 and PV is equal to 4. Here's another example that's a little bit more complex. AD, BE, and CF are medians of triangle ABC. What is the measure of segment CD? If CE is 4x plus 3 and DB is equal to 5x minus 1 and EA is equal to 2x plus 9. Well, it's important to realize that all of the shapes that are here, AD, BE, and CF are medians, but CE, DB, and EA are on the outside. So I know that CE is going to be congruent to EA because since this is the median, the sides are cut in half. I know that DB is going to be congruent to CD because the medians cut the outer edge or the perimeter, they cut each of the sides in half. So if I look at what I am given, CE is equal to 4x plus 3, DB is equal to 5x minus 1, and AE is equal to 2x plus 9. Well, now I need to go through and I need to find CD. Well, This is one of those hopscotch problems. There is nothing to help me find CD except that I know CD is equal to BD. And in order to find BD, I need to know what X is. Well, there's nothing for me to say what this is equal to, but if I look on this side, I can see that 2x plus 9 is equal to 4x plus 3. And you won't see this unless you mark your picture and actually examine the question. If you try to do this in one step, there really is no way to do that. So I set up this equation because the outer edges are congruent, and now I solve. I subtract 2x from each side, and I get 2x over here. I subtract 3 from each side, and I get 6. I divide by 2, and I get that x is equal to 3. Well, now that I know what x is, I can just substitute that into that equation. 5 times 3 minus 1 gives me 14, and therefore CD is equal to 14. Here's an example for you to try. The correct answer is B. So if I look at this, I know that LR is what I am looking for. That's the bigger segment. And I know that that is equal to 2/3 of the whole thing, which in this case is 30. I divide 30 by 3 and I get 10, and then I multiply it by 2, and I get that LR is equal to 20. And if I remember correctly, this is 20, and this segment is just half of this segment, and therefore that's going to be 10, which is why B is my correct answer. Here is another example for you to try. Please note that the segments that are marked are on the exterior. Eight is the correct answer because even though it doesn't say that these segments are medians, because each of these segments on the outside are marked as bisected, and each of the segments like LO starts at a vertex and goes to the opposite side, I know that all of the interior segments are medians. Well, JP is 16, and it wants me to find PM. Well, remember, it's just 16 divided by 2, which means I have 8, because this is 2x and this is x. That concludes this section on medians.